Introduction: the majority of existing smart contract platforms, while supporting trustless executions of arbitrary programs, lack access to real-world data. This limitation hinders the maximum potential of such contracts. Band Chain was created
to solve this issue
by connecting public blockchains with these real-world, off-chain information. The project was created with the following design goals: speed and scalability. The system must be able to serve a large quantity of data requests to multiple public blockchains with minimal latency and while maintaining a high throughput. The expected response time must be in the order of seconds. Cross-chain compatibility. The system must be blockchain agnostic and able to serve data to most publicly available blockchains. Verification of data authenticity on the target blockchains must be efficient and trustless by nature. Data flexibility. The system must be generic and able to support different methods of retrieving and aggregating data, including both permissionless, publicly available data as well as information guarded by centralized parties. Band Chain achieves the aforementioned goals with a blockchain specifically built for off-chain data curation. The blockchain supports generic data requests and on-chain aggregations with WebAssembly-powered Oracle scripts. Oracle results on Band Chain blockchain can be sent across to other blockchains via the Inter-Blockchain Communication Protocol, IBC, or through customized one-way bridges with minimal latency. Terminology: data sources. A data source is the most fundamental unit in Band Chain's Oracle system. It describes the procedure to retrieve a raw data point from a primary source and the fee associated with one data query. On Band Chain, a data source can be registered into the system by anyone. This is done through the registrant sending a MSG create data source message to the chain. In this message, they specify various parameters the data source they wish to register, including, the sender who wished to create the data source, the owner of the data source, if specified, the name of the data source, phase 2 plus, the per query fee that someone looking to use that data source needs to pay, the content of the executable to be run by block validators upon receiving a data request for this data source. When registering the data source, the message sender can choose whether to specify an owner of the source. If an owner is specified, only the owner can make any changes to the data source once it is registered. They will also be the only party able to collect the accumulated request fees. On the other hand, if an owner is omitted, the data source can no longer be edited after it is registered. Note that the sender who creates the data source and the owner of the data source does not need to be the same. In the case of unowned data sources, it is the data source's configuration on Band Chain that cannot be changed. If the procedures associated with that source depends on centralized sources, the actual source of the data can still be controlled by centralized parties. Examples. The following two examples illustrate what a data source executable might look like. Both examples are written in Bash. Retrieve cryptocurrency price from CoinGecko. The data source requires that curl and JQ are installed on the executable runner's machine and expects one argument, the currency ticker symbol. ! Binge URL equals https://appy.coingecko.com/appy/v3/simple/price IDS equals $1 and VS currencies equals USD key equals $1 dart USD curl SX get $URH accept application shin JQR $1 dart USD. Resolve hostname to IP addresses. Again, this script assumes that JETant and AUK are available on the host and the host is connected to the DNS network. ! Binge JETant hosts $1 AUK, print $1. Oracle scripts. When someone wants to request data from Band Chain's Oracle, they must do so by calling one of the available Oracle scripts. An Oracle script is an executable program that encodes the set of raw data requests to the sources it needs. The way to aggregate raw data reports into the final result. These sources can be the data sources published on the network, as well as other Oracle scripts. Oracle scripts are also Turing complete and can be programmed in multiple languages. This composability and Turing completeness makes Oracle scripts very similar to smart contracts. To create an Oracle script, the creator must broadcast a MSG create Oracle script to Band Chain. The contents of the message includes the sender who wishes to create the Oracle script, the owner of the Oracle script, if specified, the name of the Oracle script, the OWASM compiled binary attached to this Oracle script, the schema detailing the inputs and outputs of this Oracle script, as well as the corresponding types, the URL for the source code of this Oracle script. Similar to data sources, the sender who wishes to create the Oracle script does not have to be the same as the owner of the Oracle script specified in the message. The execution flow of an Oracle script can be broken down into two phases. In the first phase, the script outlines the data sources that are required for its execution. It then sends out a request to the chain's validators to retrieve the result from the required data sources. The contents of this consists of the data source's execution steps and the associated parameters. The second phase then aggregates all of the data reports returned by the validators, with each report containing the values the validator received from the required data sources. The script then proceeds to combine those values into a single final result. Note that the specifics of the aggregation process is entirely up to the design of the Oracle script. Bandchain does not enforce any regulations when it comes to the aggregation method used, and entirely leaves that design decision to the creator of the script or any subsequent editors. Example: the pseudocode below shows an example of an Oracle script that returns the current price of a cryptocurrency. The script begins by emitting requests to validators to query the price from 3 data sources. That is, the request function calls to CoinGecko, CryptoCompare, CoinMarketCap, and SidePrepare. Once a sufficient number of validators have reported the prices, the script then aggregates and averages out the reported values results into a single final result, the aggregate function. In this particular Oracle script, the aggregation process starts by summing all of the price values returned by the validators across all data sources, as well as the total number of reports returned. It then simply divides the summed price value with the number of data reports returned to arrive at the final average value. First phase emits raw data requests that the Oracle script needs. Def prepare symbol request get px from CoinGecko symbol request get px from CryptoCompare symbol request get px from CoinMarketCap symbol. Second phase aggregates raw data reports into the final result. Def aggregate symbol number of reporters data report count equals 0 price sum equals 0.0 for reporter index in range number of reporters for data source in get px from CoinGecko get px from CryptoCompare get px from CoinMarketCap price sum equals receive reporter index data source symbol data report count plus equals 1 return price sum data report count raw data reports. Raw data reports are the results that Bandchain's validators return when they have successfully responded to a data request and subsequently retrieved results from the required data sources. In these reports, the validators list out the result they got from each data source, using the data source's external ID as the reference key. The external ID is the identifier used to reference a data source within an Oracle script, and each data source's external ID is unique within the context of that script. Oracle data proof: when the final data request result is successfully stored onto Bandchain, an Oracle data proof is produced. This proof is a Merkle proof that shows the existence of the final result of the data request on Bandchain. In addition to the actual result value of the request, the proof contains information on the request parameters, Oracle script hash, the parameters, the time of execution, etc., as well as those of the associated response. For example, number of validators that responded to the request. This proof can then be used by smart contracts on other blockchain to verify the existence of the data, as well as to decode and retrieve the results stored. Both of these can be done by interacting with our light client.
High-level overview.
Band Protocol is a cross-chain data Oracle platform that aggregates and connects real-world data into peers to smart contracts. Band's flexible Oracle design allows developers
To query any data, including real-world events,
sports, weather, random numbers, and more. The Bandchain Oracle. Oracle solutions such as Bands act as the middle layer, operating between the smart contracts or decentralized applications and the various data sources. Their task is then to handle data requests coming from the dApps, query the data from the corresponding data sources, and report the results back to the application. Oracle as the middle layer. Band's Oracle then differentiates itself from other Oracle solutions in 4 main ways. Copy-link decentralization. First is decentralization. Our Oracle infrastructure is built for maximum redundancy on 2 separate layers. 1. Our blockchain, Bandchain, is operated by a globally distributed pool of validators, whose performance and actions can be easily monitored and verified by anyone. When a data request is made, it is these validators that will be responsible for fetching the results. These results reported by the validators are also taken from multiple sources, which acts as our second layer of redundancy. On this point, Bandchain's delegated proof-of-stake design further help ensure that these validators have monetary incentives to properly and correctly report the data, or risk losing the capital they've staked as well as their reputation. Finally, the entire data request flow and validator performance are publicly available to be viewed, verified, and audited by anyone. Copy-link flexibility. Next is flexibility. Band's Oracle is built to allow maximum freedom in terms of the data that can be requested, as well as the computations and mutations that can be done on that data. This is made possible through our data sources and Oracle scripts. Data sources are the most fundamental unit in Bandchain's Oracle system. It specifies the primary source from which Bandchain's validators will retrieve data. An Oracle script is then the pieces of code that defines the logic of the data request. In particular, the script specifies 2 things. Not only that, we're also able to offload all the heavy Oracle computations from the requester's chain and onto Bandchain, which have been specifically optimized for these sorts of computations. All this boils down to the fact that an average data request to Bandchain's Oracle can be expected to resolve in less than 6 seconds. Cost. Finally, there's the issue of cost. Band's Oracle allows anyone looking to request data to do so only when they need to, and pay the associated fees on a per-request basis. This is significantly more economical than having to say, update the price of an entire set of assets, when in fact you might currently only need the latest price of one.